5-1 roots of real numbers. When we are taking square roots of something, we have to make sure that we are expressing this as both a positive and a negative. We have different parts of these radicals. Our index is the little number that's on the outside of that radical sign. Sometimes you do not have an index, and when you don't, it's automatically a 2. So what you're saying to yourself when you're taking the square root of something is what times itself is the number underneath the radical. So if we look at example A, under example 1, we're just simplifying. So we can actually look at that 9 and say, what times itself is 9? Well, 3 times 3 is 9. So the square root of 9 is both positive 3 and negative 3. So plus or minus 3 is the square root of 9. The only time that you will not have to do that plus or minus is if there's something like B where you have a negative square root of 9. So we know that 3 times 3 is 9, but that negative out front is going to tell us that it's negative 3. So the negative square root of 9 is negative 3. For C, we have a fraction. When we have fractions, this radical goes over both the top and the bottom of that fraction. So it's like saying the square root of 1 over the square root of 9. We know that the square root of 1 is 1, and the square root of 9 is 3. So that's plus or minus 1/3. For D, we have 0.09. So that 9 is in the hundredths place. So this is the same thing as saying 9 over 100 underneath that radical. So again, we would do the radical or the square root of 9 over the square root of 100 and make sure you put that plus or minus out in front of it. Now the square root of 9 is 3, the square root of 100 is 10, so it's plus or minus 3 over 10 or 0.3. Now the only reason why we can give this as a decimal is because it's given to us as a decimal. So we can only do the decimal form of something if it's given to us as a decimal. With the fraction, you could do either or. Okay, so which means your answers can be fraction form for what's given to you as a decimal or what's given to you as a fraction. If we look at our next part, we're finding the real roots of each equation. If there are none, we're saying so. So if we look at the first example, we have x squared is equal to 9. If it's just x squared plus a number, x squared minus a number, we're going to move that term to the other side to where we have the x squared by itself. And then we would take the square root of both sides. So here, because that 9 is positive, we can do this, and x is just going to equal plus or minus 3. However, if we look at example B, we have x squared plus 4 is equal to 0. We want to move that 4 over by subtracting it, and we're going to be left with x squared is equal to negative 4. If we take the square root of both sides, because that negative is there, we cannot do that, so there are no real roots here. If we look at our next example, C, we have 5x squared is equal to 15. So we're going to take that 5 and divide it by each side. And we're going to be left with x squared is equal to 3. We then take the square root of both sides. When we do this, we cannot take the square root of 3, but it is a positive, so we can do that. We just have to put that plus or minus out in front of it, and then we're done. So it's x is going to equal plus or minus the square root of 3. For D, we have 6x squared is equal to 108. We're going to divide each side by 6. We're going to have x squared is equal to 6 goes into 10 one time with 4 left over. 6 goes into 48 8 times. So we're going to have to take the square root of both sides. Now, we don't know what the square root of 18 is, so find the prime factorization of it. You have 9 and 2. That 9 factors out to be 3 and 3. You have a pair of 3s, so pull 1 out. So x is going to equal, remember that plus or minus 3. The 2 doesn't match up with another 2, so it's going to stay underneath the radical sign. So plus or minus 3 square root 2. For example 3, we're simplifying the cube root of 8. So the same thing that we just did, we're going to find the prime factorization of the number. We have 4 and 2. That 4 breaks down to 2 and 2. We're looking for a group of 3. These 2's are a group of 3, so this is just plus or minus 2. And the reason why this can be both is because a negative 2 times a negative 2, it cannot be both. So this should only be a positive 2, So a positive 2. The reason why is because that 3 is odd. If the index is odd, you want to make sure that whatever sign is underneath the radical, your answer has. So because the 8 is positive underneath, the 2 is positive as the answer. For B, we have the cube root of negative 27. So we do have that negative there. We're going to make sure we keep that with our answer. 27 is 3 times 9. 9 is 3 times 3. We're looking for a group of 3. We have one here. So this is going to be negative 3. The cube root of negative 27 is negative 3. For C, we have the cube root of 10 to the 6th power. Remember, this is the same thing as the cube root of 10 times 10 times 10 times 10 times 10 times 10. You're looking for a group of 3. So here's a group of 3. Here's a group of 3. So this is also 10 times 10, which is 100. So the cube root of 10 to the 6th power is 100, or 10 squared. You could also do the 6 divided by the 3. So this is the same thing as saying 10 to the 6th divided by the 3rd is 10 squared, which is 100. For D, we have the cube root of a to the 9th power. So again, we can write this out as the cube root of a times 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 a, and then group up the numbers by 3. So 3, 3, 3. You have an a times an a times an a, which is a cubed. We could have also done a to the 9th divided by the 3rd, which is a to the 3rd. So the way that you would work these is whatever exponent the term has underneath the radical, that's going to be the numerator, and the index on the outside of the radical is going to be the denominator, and then you're just going to divide them. If we look at our next set of examples, we are simplifying these. So for example 4a, we have the 4th root of 81. So we're going to find the prime factorization of 81 first. So 81 is 9 times 9. The 9 is 3 times 3. So we're looking for a group of 4. So this all is a group of 4, so it's just going to be 3. However, that index is even. So because it's even, we're going to put that plus or minus out in front of the 3. For B, we have the 5th root of 32. So 32 is 4 times 8. 4 is 2 times 2. 8 is 2 times 4. 4 is 2 times 2. So we have 5 as our index. So here's a group of 5. So it's just 2. The sign underneath, because it's odd, keep the sign underneath, which is positive. So it's just a 2. For C, we have the 5th root of negative 32. The 5th root of negative 32. So because it is odd, we're going to keep the sign underneath. 32 is 4 times 8. 4 is 2 and 2. 8 is 2 and 4. The 4 is 2 and 2. So we're looking for 5. We have 5 2's. So you're going to keep the sign underneath the radical and then put the 2 with it. For D, we have the 6th root of negative 1. The 6th root of negative 1, because this is even, this sign here tells you that you cannot do this. So there's no real roots. If there is a negative underneath that radical sign and your index is even, it's not possible. You cannot do it. And then here's your last part, and you're done.